My name is Scott Croft. I'm a senior architect with Red Hat, and this is Santillan, who's also a senior architect with Red Hat. I'm in the public sector. Today, we'd like to present to you the title of it, Digital Transformation of a Tactical Fighter, DevOps at High Speed. So, customer, I'll preface it ahead of time, customer and platform won't be named. But we'll talk about how they went through this digital transformation and hopefully the long-term success of what we provided them. So we went through and evaluated their environment, decided that they would be a good customer for the Open Innovation Labs, which is our environment that Red Hat goes into a customer and presents to them how to do agile development the Red Hat way. So there's all these different methods. Lewis could speak to that a lot more. He's more of a developer. I'm a platform guy, but at this customer, I'm the enterprise architect for them. So we decided to take the information that we gained out of what we did for them and present it for you today. So the current environment, they had, and they still do have, multiple vendors with multiple inputs. And the problem with that is every vendor writes their code their way, their style. They develop at their own pace. And there's no system or process that is the same for any one vendor. And it's not dictated. So the very end customer, the government, decided that these guys needed to all do it the same way. So they went to the vendors, they went to this specific contractor, and they said, we want you all to do this the same exact way. So they came to Red Hat. We said, oil sounds like this is what you should be doing. And we asked them what their main pinch points were. The biggest one, probably the two biggest ones, were they're going from the start of a coding project till the time it got to the platform. It was taking 9 months. And this is going through all their testing, all their evaluation. And it's not just testing underground, but it's flight testing as well. And it presents a strong challenge to the customer to be able to get this out there rapidly. So if the people that are in the aircraft want to change to it, they have to really plan ahead because it's going to take at least 9 months to get to that point. Then the other problem they ran into was they're getting into platform and they go to start it up, and 50% of the time, software fails. So they have to restart it all and start the process. So instead of it taking 5 to 10 minutes to start the aircraft and to get it going, now it's going to take 20 to 30 minutes, and it may take longer because they may have other failures. So they needed to be advised on how they can get better at producing software that's not going to run into this issue. Then the last thing that was an issue with them was because they have multiple vendors and they have multiple groups working on the software, there's no really good up or downstream communication back and forth. So, and Lewis will get into that as well, but in essence, there's no CI/CD pipeline. So there's no backwards or forwards communication within the software development lifecycle for them to be able to understand where the challenges are at. So they came to us with the challenges that we identified as they want new and improved methods to be employed, getting software to the platform faster, reduced OS footprint, using COTS products, and it to be a repeatable process. So they want to use agile development techniques that are employed in the commercial world today. They had tried to attempt to employ SAFe within their environment, but decided that that was just not the right approach. They're looking at other options other than Red Hat, but they wanted to see how Red Hat could help them become faster and better at what they're doing. So again, as I mentioned before, Open Innovations Labs and their approach to agile software development is what we recommended to them, and it's what we did. So we went from a process of them taking the code and putting it in their pipeline that they had, and all these manual steps that took place, and we helped them automate it. And once you automate that, it automatically increases your efficiency because you don't have to worry about this person approving this and going to the next person to approve and going to the next person to approve. And we've heard that multiple times today in multiple sessions. I'm sure you guys are probably getting sick of hearing the same things repeated over and over again, but it has to hit home. I mean, that's our whole point, is to improve your process development and improve how you do things, make yourself more efficient, and your colleagues and or the people that report to you, they can become more efficient, and you can utilize them in other areas that you wouldn't normally do that with. The reduced OS footprint, we started out with an install base of Red Hat Enterprise Linux of about 2.1 gigs. So the problem with that, if we were on a server, it's not a big deal. And this is on a server, but it's the size of a hard drive in a desktop. It's a Xeon processor with 12 cores, 16 gigs of RAM, and 32 gigs of flash. So if they're going to load a bunch of containers onto this with their software running, they've got to limit how much of a footprint the OS takes. Initial stab at it, just telling them, don't use the kitchen sink. We took them down to 1.2 gigs. They were happy with that. So we took a different approach and analyzed what they were using their software for, what they really needed access to, and I will pat myself on the back. I got them down to 244 megs. So that's 244 megs that is, I mean, they don't have to worry about it. That's a drop in the bucket when you've got 32 gigs of flash RAM. The other dictate that they had was they needed to use COTS products. So instead of writing their own custom operating system, and instead of building their own custom hardware to put on the platform, they needed to go out, and the hardware they're purchasing is made en masse. You can't necessarily go down to Fry's and buy it, but you can get it from a producer, and it's readily available. The operating system. We do the operating system, and we do the operating system very well. Yes, I'm very biased about that, but it's Red Hat. And they don't have to worry about employing a whole army of people to develop their own operating system. So that gives them that advantage as well. And the overall cost in the end is a lot less. One of the biggest things was repeatable. They're always, I would say, reinventing the wheel. They're constantly going and saying, yes, we can do this better, so let's do it this way, but they don't reevaluate how they did it before. So moving forward, they want to have a repeatable process of be able to go in and develop this software over and over the same way, multiple teams develop the same way, so that if they have to cross-pollinate with their developers, one developer that worked on one specific part of the project can move over to a different part of the project and provide the same agile intelligence and provide that way. So I'm going to stop here and let Louis take over and talk about the transformation process and let you guys know how the customer did that way, and he'll finish up with what the end results were.
So one of the big tenets of Open Innovation Labs for Red Hat is that when we start to transform an enterprise, we start by isolating one team, right? We want to experiment first, find one team that's a good candidate. Maybe they got a tough problem or the next release, but we want to start with one team, right? We isolate them, take them out of their daily workflow, because what we're doing is pretty intensive, right? It's an 8-week process. And so any distractions from operations or administration, those take away from the learning experience of that 8 weeks. So isolation is the first thing. We then pick a use case, and we start with management. We take the developers, get them all in a room. We let them identify what the use case is for the next 8 weeks, right? What value they're going to deliver to the business. And so sometimes it's an experiment, sometimes it's a production ready capability. In this case, it was a production ready capability. And then we start teaching them new methods, right? First thing we do is we start with a social contract, right? Social contract dictates how the team is going to collaborate with one another, especially in the spirit of DevOps, right? DevOps, you want to change fast. You want to take the emotion out of the development process, take the blame out of errors, because those things are not beneficial to the end product, right? So social contract says, hey, we as a team agree, we're going to measure, right? If something fails, we're going to identify why. We're not going to blame. We're going to not talk over each other. We're going to work in a collaborative fashion and make our decisions based on data. So that was one of the great things this particular team worked well with, right, is picking a social contract. Many companies today use stand-ups and scrums, daily scrums. That's common practice nowadays. What we did here, though, was we kind of isolated the scrums to just the development team, right? So there was an architect, there were 6 developers, plus a product owner. So the product owner was supposed to shield away from management, ensuring that management's goals and business requirements were being met. But then the development team didn't have to deal with all 3 managers above them to identify what work they needed to do for that day or for that week. So there's a little level of buffer in between the team and upper management, and focus for that team.
Everybody had a say.
And everybody had a say, though, right? So we had ideas flowing up, ideas flowing down, and so we kept everybody in the loop in that way. Next, we really focused on teaching them how to automate their whole entire CI/CD workflow. They had some automation around unit testing, not fully automated, but what we did is we took a suite of about 10 applications that all interacted with each other and developed several pipelines, a dozen pipelines, that actually fully tested the entire workflow, right? So all 10 apps would start up, they talk to each other, they communicate, they send messages across a bus, and they had the whole kit and caboodle tested, right? This was not something that they had in their own lab environment. So they could test 1 or 2 components in isolation, but they couldn't test all 10 applications running on this platform. So that was a really great benefit for them. They could see up and down the feedback loop, right? So if I made a change in a downstream API, I wouldn't maybe see that in my tests at a unit test level. Somewhere down the line, there was a functional or integration test. That would kick off a red flag. Hey, something broke. Figure out why it broke, look at the logs, look at the data, and then understand what needs to be fixed. So
With automated testing, they were also able to remove the human touches in there. Because previously, they had people would have to physically look at the code, sign off on it, pass it to the next guy. That guy would have to do it. But by automating this testing and the code evaluation, then they could see it electronically and it was already done. And they knew that it didn't have human hands touching it and messing with the code at all. So it improved the process there.
Next, we taught them some other ceremonies of domain-driven design and agile development. Demos at the end of every sprint was a big key for them. Being able to show management, hey, look, you asked for this change, came up this sprint, this is what we did, this was our solution. You can give us feedback now. Does this look good? Do we need to modify something? Is there a new ticket that needs to be created? Did I break something in a downstream? So the ceremonies, especially with respect to the retrospective and end of sprint demos, really helped them to give that feedback up the chain. So, and again, part of the retrospectives was learning from what you did, measuring if anything, there was any decrease in performance or any new code smells or bugs. They had integrated Sonar Cube into their pipeline. So every time they committed a piece of code, it would get rescanned by Sonar Cube, check for bugs, check for vulnerabilities, any insecure libraries that they might be including in their work. All that was all integrated and learned from in the retrospectives. And again, I've said this a couple times, the upstream and downstream feedback loops were invaluable to that one team. So kind of at a high level, this is kind of the workflow Red Hat recommends for continuous integration and continuous delivery. Got developers, they're writing whatever application, they're building their code, and we use an external artifact repository to build a container, right? Once that container is there, we move it across the continuous delivery pipeline. We'll build the image again on a dev cluster. We're using OpenShift underneath along with Jenkins. And so part of this particular customer's use case was also to build RPMs. So not demonstrated here was actually at the end of UAT, if everything looked good, we would actually build an RPM that then sub-teams and dependent teams could use for these particular applications. So this was not a normal web application that OpenShift is used to host and deploy. They were actually C++ apps. So kind of a new ground for a lot of us at Red Hat, but a use case that actually works really, really well for this particular customer. So again, we mentioned that OpenShift was underneath all of this. The team that we took into the Open Innovation Labs really appreciated the self-service, being able to stand up a new pipeline on their own, being able to stand new projects and applications on their own, the automation, being able to just commit and have the code all retested. Huge wins for the team. Collaboration, they could see each other's work, and it's all standards based, right? So once they developed a standard and it was in their Git repository, they could just clone the standard and extend from there. So, and then all the other great things that Red Hat provides on top of Kubernetes and OpenShift, the web scale, open source, enterprise grade and secure, they really appreciate having those qualities in their platform. Good. So, part of the new delivery method was how well did they accept these new delivery methods. This particular team has actually started to spawn sub-teams. They're actually starting to teach other teams informally, grassroots, within their organization, right? So kind of a really great grassroots way of building a standards process. They started talking to their colleagues, started to talking to the other teams that they work with and integrate with, and people were really interested in learning about the platform, using the platform, and the tools and techniques and working with this team now, right? Before, it was always a chore, worried about dependencies, version mismatches, and integration challenges. There's lots and lots of acceptance happening now at this company.
Yeah, the really nice thing about the collaboration that took place is they took a disparate number of people who hadn't worked together in a development environment and put them in here. We went through the social contract, we went through all these steps, and Red Hat's ability to bring this team together and work together, they immediately, as soon as we got the pipeline up, they immediately started developing software and producing software that they weren't able to do before. The reduction in time, they were spending previously about 70 to 80% just on process. So it was 20 to 30% actual coding. And that was very frustrating for that development team because they want to code, they want to produce the software, they want to be given something brand new and get it out the door in a couple of weeks, maybe even get it out the door in a week. It just depends on what is required of them. They understood the fact that if you fail fast and fail often, that you're actually more successful. It's like Chris Short said earlier today, that when you don't try to eat the whole pie, you take it in slices, develop it in slices, produce it in slices, you're actually going to come out with a better product in the end. So it's just little steps at a time, and that gets you to the bigger picture. So the reduction in delivery time for them, when they got through with this 8-week process, they felt that they went from 70 to 80% of the time working on process to about 30 to 40% of the time working on process, and they were able to code more of the time, and they were able to collaborate on that. As Lewis mentioned, they didn't have people walking by doing, as we refer to, drive-bys. Oh, hey, can you do this for me? Hey, can you come to this meeting? Hey, can you do this? And it's not necessarily a requirement that you isolate people all the time, but once they learn how to operate that way and you empower them, you give them the ability to turn around and say, yeah, you know what? I really got this deadline due on this right now. I can't do that. I can't be jerked out of this process. So let me finish this, then I can give you some of my time. And we were able to give the team that power to give feedback to management instead of that it's always top down. This is what you got to do. You got to get it done now.
Another great measurement was we had finished the project with them, came back about 3 weeks later, did a health check, and they had pushed 120 changes without Red Hat in 3 weeks. And I mean, for a team of 6 developers, amazing velocity, right? To be able to change 40 changes in 1 week on average. I mean, imagine being able to attack 40 new features in a week on every single product that you work on, right? That is a huge win for them. And they're just excited trying to share this new technique with the rest of their company.
We appreciate your time. If you have any questions, feel free to ask. Yes, sir.
I think you mentioned something about with your customers that they tried the SAFE framework and
Yes.
it failed. Do you have any insight on why that failed?
So the main reason that we were given that it failed is because they were trying to implement it in bits and pieces. And because their environment is very fluid, where they move developers from one spot to the next all the time, this guy would be really good as an agile coach. They'd shove him into a group, and then 2 weeks later, when he's just getting going, they're like, oh, no, you got to go work with this group now. So if you don't, it's not necessarily throwing good money after bad. It's throwing good money after money already spent. And if you aren't all in, and you don't make that change, it's gonna fail.
And part of the Open Innovation Lab's teachings and techniques is that you want to build a team, right? People have different roles on the team, so throwing an agile coach around wasn't successful. But if you take a team, build up a team and their capabilities, they can then work on any single product, right? Because they have that working cohesion, and just like in sports, right? You can take a good team, put them in any city, right? And so that's really what we tried to stress, right? Whereas whoever was teaching SAFE was stressing role-based flexibility, which didn't help them in their environment.
Yes, sir.
I don't know if I missed it, but on one of your early slides, you talked about automating the feedback loop both up and down. So I don't think it was within just the context of like automating testing and failing faster than learning about your failures, but
No, for instance, I think I understand what you're saying. For instance, if you want to automate the feedback, make it bidirectional, say you have security folks that are involved. Instead of sending them a folder or sending them an email saying, hey, go check this out, you set up an automated process to notify them when a piece of code has gone through testing and it produces a report that's saying this has been scanned and this is the results of the scan. And they can look at it and say, oh, wait, those red X's aren't good. And they can turn around and say, no, this isn't approved for deployment. So as soon as they check that not approved checkbox, then it goes back to the guy who wrote the code and it tells him, hey, you're not passing these 2 things. You got to fix them. He fixes them, puts it back through the pipeline again, and you didn't have to go to 4 or 5 managers. You didn't have to have a meeting that's 2 hours long discussing why those 2 things are that way. You let the guy fix his code and move on. He takes ownership of it. If he can't fix it because he's working on another story, the guy next to him who has the same ability, he fixes it for him and pushes it through.
One other innovation was that we introduced them into chained builds, right? So application A depends on B and C. You got to start with B and C first, right? When those builds succeed, then your application A will rebuild. That was something they didn't have before. They were building these components independently,
Yeah.
but they weren't chained and they weren't managing the dependencies in their build pipelines.
And in that case, how was application A aware of builds to application dependency?
So OpenShift is able to manage or track when a commit comes through a webhook, and those webhooks were triggering the builds. So
Sorry. Answer questions, please. What role, so was there CC in your environment, or CM or CC, however you guys call them, change control, change management? Were they big players in?
So in this particular case, we
Yeah.
didn't have a configuration manager. That was actually part of the architect and
There was
Scrum Master?
some manual input with regards to that because of how their environment is set up. Everybody here either works with or works for or is associated with the government in some sort of way. So even the contractors, have their requirements of how their environments can be set up. So we couldn't bring in software and just install it, hey, let's download it off the interwebs and we're going to put it in your environment. It's a long drawn out process to get it approved if it wasn't previously approved. And this particular customer, even if the government has a list of pre-approved software from Red Hat, no, they still have their process to follow. So we didn't employ that. It was something that was addressed, and it's something that's being worked on now. And there's tools that they would like to employ to be able to do that. They actually are talking about writing Ansible playbooks to do some of that for them.
So the software was OpenShift in their development environment, the test environment, but it was just Docker containers on the platform itself?
So the end platform had three different approaches to the end platform. Running it on straight Red Hat Enterprise Linux and installing RPMs. They produced packages. They'd never produced RPM packages. Within 3 days, we had them producing their own RPM packages. And if anybody's ever written a spec file for an RPM package, you understand the challenges there. That's kind of like one gentleman was Jamie Duncan was talking about YAML files for Ansible playbooks or Docker configuration files. Don't let something do it for you automatically. And that's what we set them up to do. So we took it a step further and we let them build Docker containers. So then they would run their application under a Docker container on that same platform. Then we also, as a side experiment, it was out of scope of what we were there to do, but a couple of us had a few extra cycles, so we installed Atomic on the platform. And then they put their container running on Atomic. The Atomic footprint is way, way bigger than they would like. So
they never ran OpenShift on the target?
No. And that's not the goal. That would...
not yet. That's my goal.
Yeah, we would love to see that happen.
Containers on the plane.
Any apps, flight safety, critical?
No, this particular software was not flight safety associated, but it was more platform management and monitoring associated.
Yeah. Health management. Systems health management.
When I first heard of this project, and I'm going to talk about it, my interest was around these are usually real-time OSs.
Actually, the OSs that they wrote for the platform originally are not real time. They don't run any faster than Red Hat. We can make tweaks to the kernel and make it run faster and get it to run more like the financial services and how they like to run real time Red Hat. The problem with that is supportability. The long-term plan is to switch over their entire process, but there's also other contractors that are involved in getting that done because this particular customer doesn't actually deploy the software to the plane.
Do you guys see flight dynamics being part of this?
Yeah.
Yeah.
We actually see the entire platform being run on Red Hat Enterprise Linux eventually.
So we actually have a follow-on project right now in flight, and some of the other teams that are associated with this team are in those areas.
Any more questions? All right. We thank you for your time.
Thank you.
Thank you.